Hi, good evening. Welcome to another session of this course ABW504. Today we will be looking at a topic called data preparation and analysis. I've already shared with you the materials for your project. I already shared with you the materials for your project. You should have downloaded and look at them so that when I start discussing some of these issues, you will see where they belong to. So today we will be using the software called SPSS. I will explain some of the things you need to do as part of your project. So you have to listen carefully to some of the discussion. So when we do research in business, we follow this reasoning. We have several reasoning we can follow. We have inductive reasoning, which uses qualitative research method. Since we are doing statistics, we will not cover that. We will be using this reasoning called deductive reasoning. In deductive reasoning, you will do quantitative research. So in quantitative research, you usually begin with a theory. Let's say you want to explain why your employees are not committed to your organization. So that is, then you look for a theory that explains organizational commitment. Yeah, Soraya, what? Soraya, you have a question? Based on that theory, we will develop a research model. And from the research model, you will develop a hypothesis. And based on the model that you develop, you need to collect your data and analyze your data. Then only you accept or reject your hypothesis. So when you collect your data, we will also discuss a bit about whether you use primary data or secondary data, objective data or subjective data. There are also some choices that you can make during the data collection stage. Okay, let's say we want to study these two relationships, job satisfaction and organizational commitment. These are the two variables we have, which are very abstract concept we have. We want to test them. But before we can test them, we need to actually measure them. So this is what we call as the theoretical plane. The theoretical plane will explain that in many other prior studies, job satisfaction leads to organizational commitment. Okay, but what we need to do is we need to bring this theoretical level to an empirical level. Empirical level is how do we actually measure this variable called job satisfaction? How do we measure this variable called organizational commitment? So this is where we have the two stages. So if you look at the diagram here, we have these two planes. The first plane is the theoretical plane, where we link these two constructs, construct A and construct B. This construct A and construct B is not named here, right? So what happens is we will go to the theory. The theory will give you what are the variables that leads to this variable. And then what we do now is from this level, we need to bring them to a measurable level. This is what we call as an empirical plane. So when you bring this level to this level, there will be some gap. This is where we will discuss a bit about when we are doing primary data collection, we will have an issue called validity reliability. So what is meant by the empirical plane is like this. I want to measure job satisfaction, and I have three questions to measure job satisfaction. In the literature, they will mention as item, elements, those are all referring to the same thing. So the construct or the variable you're interested in is job satisfaction. And job satisfaction has three items, 1, 2, and 3. Organizational commitment, we have item 1, 2, and 3. This is what we meant by the empirical level. So from this empirical level, we need to collect the data from the respondent we want to analyze. We can analyze the same relationship at the organization level or at the individual level. So this is where we have two types of data, primary data and secondary data. Primary data is data that you collect for solving the problem that you want to solve. That is called primary data. Secondary data is data already collected by others, but you can still use the data to solve the problem you currently have. So this data is collected solely for your research, whereas this data was collected by somebody else, but you can still use them for your analysis. Let's say you look at a database, they have data about sales figures or ROI, ROA of companies. We just take that and model. We can also do that. That's where the difference between primary and secondary data comes in. So let's say we want to analyze these three variables. We want to see the price, advertisement, and sales. So we have these three variables. So this, when we measure them like this, this is what we call as primary data. We will use questionnaire to collect the data. We have three items to measure price. We have three items to measure advertisement. We have three items to measure sales. When we collect data like this, we call them subjective data. Okay? Subjective data. We can also collect data which is objective for the same three variables. Like here, we have pie sales, actual pie sales for the 15 weeks. And then we have the price and the advertisement. If you collect data like this, we call them objective data. If you collect data like this, we call them subjective data. So the data is still the same. We have three variables in the model. We have sales, we have advertisement, and the price. Okay? So usually in many social science and business research, we will begin with the theory. So this is an example of behavioral theory that was developed by a guy called Adzen. Prior to this 1991 paper, they actually had only attitude, subjective norm, and intention. But in 1991, they added another variable called perceived behavioral control. So this is a behavioral theory that explains why people do certain behavior. For example, exercising behavior, smoking behavior, purchasing online behavior. These are all intention that we can look at. So this intention is actually explained by these three variables, which is attitude, subjective norm, and perceived behavioral control. Attitude is your own attitude towards the intention. Let's say here is you want to buy a product online, right? Online purchase. So if your attitude towards online purchase is positive, then you will buy. Subjective norm is people around you, your friends, your relatives, your supervisors. These are subjective norm. And the third variable is perceived behavioral control. Do you have control or resources to do the behavior? So these are the three variables already identified by this theory. And many researchers, when they study intentions or behavior, they use this theory to explain. Okay? But the theory only tells you you have these 1, 2, 3, 4, and 5 variables. How do you measure them is up to you. Many researchers have many different conceptualization. So what we need to do is, first we need to find instrument to measure these variables. Then only we go out to collect the data. Okay. So these are the three variables we want to analyze for the research model. Based on this research model, we need to collect data to measure the attitude. We need to collect data to measure the subjective norm. And to measure perceived behavioral control, we have also some item and intention. Where do you get these items from? There are journal articles, many journal articles available. Some have 3 items, some have 4 items, some may have 10 items. So we usually like to collect the smaller number of indicators or items. So let's say we have already collected this data. This is how they will explain that based on the model that I have, we have attitude, subjective norm, perceived intention, perceived behavioral control, and actual sharing. Okay, again, a reminder, please mute your microphone. I don't want to expel you from the platform, right? Okay. So after we have this definition, we will also need to have the items. So here we have 5 items, 4 items, 5 items, 4 items, and 3 items. Where they come from is already given here. Okay. So these are the sources that these items are taken from. Once you have done this, you need to develop a questionnaire. Okay. So in business research, you will see lots of questionnaire being used to collect data because let's say we have a problem with customer satisfaction. We want to know why customers are not satisfied with our product. So we will need to develop a questionnaire, give to the customer for them to answer so that we can do some modeling. So this is how a questionnaire will look like. And here are some examples. So the first part can be about the demographic characteristics of the respondent. If we are studying organization, it will be about the organization. If we are studying individuals, it will be about the individuals. So here it is about the individuals working in a company in terms of their gender, their age, number of years working, and so on. And then we will follow up with the variables. So attitude has 5 items. These are the 5 items to measure the variable called attitude. We have 4 items to measure the variable called subjective norm. We have 4 items to measure the variable called perceived control. And we have 5 items to measure intention. And finally, we have 3 items to measure how much they share. So those are the variables we have in the model. Okay. So after you collect your data, now you need to convert the data you collect from the questionnaire to a form readable by the software called SPSS. Okay, so SPSS only understand numbers, right? So if you open the software called SPSS, SPSS will be shown with row and column. So here we have row and then we have column. Each row represents one case or data about one respondent. And each column will represent one question or one variable you have in your questionnaire. Okay? So the row represents the case, the column represents the item. Okay, the item. That's how the software understands. And if you look at the number here, 1, 2, 3, 4, these are system numbers. So every time you collect data, the first column will always be assigned to a number called the respondent number or the company number or the case number. So column number 1 will be your ID number. Column number 2 will start with your question number 1, question number 2, question number 3. That's how you enter the data. So entering the data, you can enter the data using SPSS. You can also use Excel and then read directly to SPSS. Both ways you can do. Okay. So for data entry, we can use this software, Excel, SAS, Lotus, Tata, DBase, or Text. These are some of the software that you can use to enter your data. And when you read the data into SPSS, what will happen is, I already mentioned that these are case, right? Case 1, case 2, case 3, case 4, and case 5. This is respondent number 1, respondent number 2. So this is ID number. And second column is representing a variable you have in your questionnaire. This is the data for respondent number 1 in terms of this variable. This is the data for respondent number 2 in terms of this variable. The only problem is we don't know what this variable 2, variable 3, variable 4 represents. That is why in SPSS we will have another stage called data definition. Okay. Why this data definition is needed? So that you can read your output more easily. Okay. So just now we didn't know which variable represents which variable, right? So what we will do now is in data definition, in SPSS, they will give you two views, the data view and the variable view. Okay, the data view is here. Okay, we see here data view. You can see all the numbers that you key in or the data you collected. When you move to your variable view, now each row will represent one question in your questionnaire from your data, right? So row number 1 represents your ID. Row number 2 represents your item number 1. Row number 3 measures item number 2. Okay, so how do you know? You have to go back to your questionnaire. So this is where we will have this stage called data definition. And in data definition, we will do 4 things. One is to change the name of the variable. We will change the label of the variable. We will do value label, and finally the missing value. What is meant by missing value is, let's say a respondent did not answer any question. What number do you use? This often happens when you do questionnaire research. Some question the respondent do not want to answer, so he can skip the question. So the first one, which is called the variable name, we will change it here. This column is called the variable name, right? So if you change the name, okay, I can change the name. You can use any language. In Malaysia, we have Bahasa Malaysia and also English. Let's say we use English. Number 1 will be ID. Number 2 can be gender. Number 3, age, organizational tenure, total tenure. What name you want to use, you can decide. But usually this name should be about 8 alphabets. Okay, the variable name, the numbers should be about 8 alphabets. Okay, the second column, which is the type, we can pick any here, but we usually will use numeric because if you change it to string, string means alphabet, no? Male, female, okay? Married, single. This will not be able to be analyzed in some of the analysis. That is why we prefer to use numeric. Okay. The width of the column is already preset to 8. Okay. If you need a bigger column, you can change the number here. Okay. But usually 8 is more than enough. This decimal place, the default is 2 decimal place. But if you are measuring gender 1 and 2, if you have 2 decimal place, it will be shown as 1.00, 2.00. But the 00 is not meaningful. So you can actually change the decimal to 0. Okay. So then you see only 1 and 2. That's the first thing you do for variable name. Then we have a column called variable label. This variable label is a longer description of the short name. Let's say you use here X1, X2, X3, X4. You can also do that. But here we will have a longer explanation of the short name. Okay, for example, your gender, right? So I put here respondent gender. Age, I put respondent age. Tenure, I put organizational tenure. Total tenure, I put total tenure. These are usually done only for demographic variables, but the other variables, you actually don't have to do that. So this is the second step, changing the label so that you can read directly from the questionnaire. The third step will be related to the value labels. These value labels are only for variables which are limited categories. For example, gender. We have 1 representing male and 2 representing female. So we can tell the system now, if you see this column called gender, any number which is 1 is equal to male, any number which is 2 is equal to female. Okay, that's how you label variables which have limited categories. Okay, we have this variable. We have this variable which is age. Age is 15, 16, 17, 18, 19, 20. For that kind of variable, you don't have to do value labels because it is 15 equals to 15, 16 equals to 16. Don't have to do that. No? Unless it is category 1 is 15 to 25, category 2 is 26 to 35, then you can do that. Other than that, continuous variable, you don't have to do value labels. And then finally, we will have the last column, which is called a missing value. This missing value in most statistic book, they will ask you to put a 999. Okay, 999. Why 999 is if you don't define the missing value and the mean value will be very large. So you will remember to go and correct them. But the best thing to do in SPSS, when anybody does not answer the question, just leave it blank. And the software will put a full stop. Okay, that will define that it's missing. Okay, we also have these measures here, right? Usually under the measures, I usually put scale. Doesn't matter what variable you have, but you can also change it to ordinal or nominal. This we will discuss in some of the classes. What is meant by an ordinal scale, what is meant by a nominal scale. In the next few classes, we will be discussing that. But if you don't want, you can put all of them as scale. Okay, that's the things you need to change. Why we are doing this step is to make our output more readable. Okay, more readable. So after you have done all this, if you look at your data view, now you can see the numbers and also some labeling because we have invoked the view which is value labels. We can see this. If not, they will not show this. So this is the first step to make the output more readable. Okay. So the data we will be using, I've given you a data set. If you look at the data set, it is already labeled for you. We see here, we have a gender, we have an age, we have organization, work, department, position, education. They are also labeled and with this category. And if you see this value label for age, for organization and work, there's no value label because they are actual number of years. Okay, like this. Can you see here? The age can be any number from 25 to 30 to 35, right? Organizational tenure, work tenure, they're actual numbers. That is why we didn't do this value label. Okay, this value label. Okay. Okay, so that is the first step that you need to do for your project also. So you will be given an Excel file. You need to read that Excel file into SPSS. You have to do the labeling. After you have done the labeling, then only we will move on to the next step called data screening and cleaning. Okay. Any questions so far on the first part? Okay. So I will quickly show you what will happen with the data. So in the materials that I gave to you, okay, this is the material I gave to you. So if you look at the data, this is the data file in Excel. So what I will do is, for your project also, you will be given a data set like this, right? So from your SPSS, what you will do is you will go to File, Open, and then Data. File, Open, Data. Okay. And then you will go to the folder that you have saved the file. If you see the Excel file is not shown, because they are actually looking for SAV file. This is called extension, .sav. So what you need to do is you need to click down and you need to change to Excel. Right? Now you can see the data. So this is the data we want to open. So if you click on the data and open, they will give you a dialog box. Okay. This is how the data will be read into your SPSS. Okay. So we have some variables and then with the numbers. Once you click the OK, what will happen is they give you these numbers. So we see here, it automatically labels V1, V2, V3, V4, V5, and so on. Because you don't have the value labels at the top, the name of the variable. This one we can change later. Like just now I mentioned, you will go to variable view, and then you can double click here. You put an ID here. Okay? And then you follow up with the changes here. So this is what you need to do for your project. So how to read the file? From here, file, open data, and then go to the folder, change the extension to Excel. Then you will see the Excel file that I have already given for your group. Okay? Any questions on how to read your Excel file into SPSS? Okay. Nope. Okay. So I just show you one example of the labeling, so that you can see. So the example I showed you in your data, you can see this. Okay. We have this first variable, which is called gender. And gender has two categories only. We don't allow third category in Malaysia. We have only 1 and 2, right? So what will happen is in your SPSS file, so here you double click and then you change it to gender. Okay, so that is a variable name. Decimal, we want a 0. Variable, we can put what is your gender. Okay. So the variable gender is measuring what is your gender. And then the third one is your value labels. When you click the value labels, number 1 represents male. You need to click the button add. And then number 2 represents female. And then add. Okay, this is how you create labels for categorical variables. Okay. Once you click OK, what will happen is you see here it is already listed. 1 is male, 2 is female. You can also look at it if you want to. And the final one is this one, missing value. If you have any number that is missing value, let's say any missing number, you put a 0, then automatically when they see a 0, they will assign as missing value. Okay, they assign as missing value. And this is how you can change your variables. Okay, let me show you that one. Okay, for the second one, if you see the age, okay, age, it is a continuous variable. They can put in 35, 36, 37. So in your SPSS, you can change this to age. And okay. For value labels, you don't have to do anything because they're actually numerical numbers, 15, 16, 17, 18, 19, right? So we don't have to label. So only for categorical variable, you will do value labels. For continuous variable, you don't have to do any value labels. Okay? Yeah. Any questions about this? Oh, okay. So if you look at the assignment that I've already given to you, this is your assignment and project. If you open the assignment and project, I've divided it into assignment and project. Okay, let me see. This one. These are the things we are covering today. The assignment part. Okay. Import the data given into SPSS. I already shown you how to do, right? And then define each variable, variable label, value label. I've also shown you. After that, only we will move on to step number 3. Okay. Okay, missing value. In missing value is like this. Okay, this missing value is when a respondent don't answer any of your question, what number you want to assign. Okay, let me show you this. Let's say this person is a bit older. He don't want to tell you his age, okay, and he didn't answer. So what you do is you leave it blank like this. Automatically SPSS will know that this is missing. You don't have to tell them what number. Okay? That is the easiest. Okay? That is the easiest. If you put a 0, you need to tell the SPSS that 0 is a missing value. If not, what will happen is when they calculate the averages, they will use 0 in the calculation of averages. If you put a blank for this variable, they will divide by 4 automatically. So you don't have to do anything. When you calculate mean, they will divide by 4, not divide by 5. Okay, so that's why we need to explain the missing value. Okay, this missing value. If you see a full stop, it's actually missing value. Okay, so that is the first time. So again, 1, 2, 3. Okay, this is what I've shown you. Okay, then we will move on to the screening and clean 1 and 2 I've shown you. Now we are moving on to screening the data and cleaning the data. Okay, so we will not use this data. You will need to open the data called data preparation. Okay, this is the full data set which I've already entered. There are 197 cases. 197 cases, and if you see the first variable is ID, right? See ID. There are also some people who ask me why your numbers are the same as here. Okay, but these numbers cannot be used in your analysis. Later, when you do an analysis called multiple regression, we will have a problem called outliers. We need these numbers for removing the outliers. So that's why we need the numbers. So if you look at the variable view, if you see ID, gender, age, organization, these are all your demographic variable. Attitude number 1, attitude number 2, attitude number 3, attitude number 4 and 5, they're actually measuring one variable called attitude. So that's how I usually label them in the data. So these are all data that is coming from this example. Attitude, subjective norm, perseverance, control, intention, and sharing. So those items are actually here. Okay, that's how the data set shows you. So we have two views. One is called a data view. The other one is a variable view. Variable view is what is called as the code book. The code book. You're telling the system that attitude has 0 decimal and there's no labeling. For example, you have gender. You are saying gender has 0 decimal, and the label for gender is what is your gender, and the value label is 1 equals to male, 2 equals to female. Okay, so that's why we call them the code book. What your items are measuring. If you see your questionnaire, okay, gender, it has only 1 and 2, right? So if you have this department which has 11, right? 11 departments, you need to label them 1 to 11, or else they will only tell you number 1, number 2, number 3, number 4 without the label. And that's why we need to key in the value labels. Okay, so this is the data set we will work on for the data screening and cleaning. Okay, so if you see in the slides, we have already done the labeling. Okay, we have data entry, you don't have to do because data is given to you, right? So you can just read the data. You need to do this definition. The variable label, the variable name, I have already assigned in the Excel. If you see your data file, okay, this is your data file. If you open the data file, if you see the variable names I have already given, so you don't have to do labeling for your variable name. When you read directly into your SPSS, they will read the variable names from here. Okay, they will read the variables name from here. But what you need to do is, after you have read the data into SPSS, you will need to do this tab, variable label, value label, and missing value. Okay, variable label, value label, and missing value. If you don't have any missing value, if you see in the data, the missing value is automatically put a full stop. So you don't have to do missing value. You only have to do variable label and value label for the data that you have imported. Okay. So this is the data we will work on. The first step we are doing now is the data screening. Data screening and cleaning. We will do two things. One is in analytics, we call this pre-processing. When you do your analytics lab project later at the end of your course, you will still need to do data pre-processing. Okay, doesn't matter what data you use, you need to do that. No? So this is for primary data. So for primary data, we will do two things. First, we will check for blank responses. What is meant by blank responses is, if you see here, they did not answer. Many items in the questionnaire, they did not answer. So when you have many answers, many questions they did not answer, if it's more than 25%, you should delete them. Okay? More than 25% of your item. Let's say you collected data, 20 questions, okay? 20 questions. And out of the 20 questions, the respondent didn't answer 6 questions. This is already more than 20%, right? Okay. 6 divided by 20 will be more than 20%. No? So you need to delete those cases which are missing value more than 20%. That's the first thing. So that is what we will do with blank responses. The second thing we will do is this issue of straight lining. This is also a more recent phenomenon they have discovered. This is where the respondent answers all the answers in the questionnaire with the same number. So they are actually not helping you. Although they fill up the questionnaire, they are only marking 4, 4, 4, 4, 4, 3, 3, 3, 3, 3, or 7, 7, 7, 7, 7. That is what we call as straight lining. These two we must clear first. Then only we look at the other issues. Okay. So to do this data screening and cleaning, we will do it in Excel. Okay, we will do it in Excel. Okay, so I will show you how this can be done. So I will post this. Okay, from the data set you already have. Okay, can you click the variable view? Variable view. And then highlight all these items until you get the last item. Okay. So after that, what you do is you right click and copy. Okay. Now what we will do is we will open your Excel. Okay. From your Excel, you can actually use Control key, right? Okay. To copy is Control C. Okay. To paste is Control V. Okay. Control V, the keyboard Control V, or you can also right click and then paste. Can you see? Right click and paste. Okay. So what will happen is all these are highlighted, right? All these items are highlighted. Okay. So here what we will do is we will right click and then copy. What we want to do is from the row, we want to convert them into columns, from the row to the column. So just click the copy. And then you go to cell number B, cell number B, And in cell number B, what you need to do is you have to right click and then you will see a function called transpose. Okay, transpose. So what we are doing now is we are changing the column into row. Okay, if you have an older version of Excel, you need to, when you right click, okay, like this, when you right click, you will have a paste special. Okay, paste special, then you will see here, somewhere here, transpose. Can you see? This is for those who have an older version of Excel. If you have the new version, you just right click and then you see this transpose. Okay? Yeah, you can try it out. No? Is it working? Okay. Thank you, Song. No? Okay. So after you have done this column is not needed. No? This column is not needed. No? Just delete. No? Okay. Now you have a blank screen, right? Okay. So what we need to do is we need to go back to our SPSS. Okay. We want to select the whole data. So what you do is, can you press Control A? Yeah? Can you see everything is highlighted? Control A. Everything is highlighted, right? Okay. Yeah. Okay. And then you can also Control C, or you can right click and copy. Okay. Both ways are possible. Control C, copy. And then when you go to your Excel, you paste. Did you get the numbers? Okay. Thank you. Okay. Cool. So now what we want to do is we want to do the first thing. Okay.
Hey, don't go away.
We want to do a blank response. Can you type in blank first? Okay. The function key we want to do is equal sign count blank. Can you see this count blank coming out? Okay. You just double click. Okay. You see the count blank, right? Okay. That's an open bracket, right? So what we need to do is we need to put all these items. Okay. Drag until you get attitude number 1. Attitude number 1. Okay. Highlight all the items which are multiple item scale, right? Okay. And then what you do is you close the bracket. Can you see here? Close bracket. Okay. Close bracket. No? And you can press enter. So what will happen is they have counted and they found that for this particular respondent, there is only one blank response, which is here. Can you see here? This is blank. Okay, that's what they are saying. Okay, so now what we want to do is we want to copy this down. This function, we want to copy it down. So what you do is when you get a plus sign, when you see a plus sign, just double click. Okay, just double click. Okay, did you get this? Okay, so it calculates how many blank responses you have, right? Okay, so what we want to do now is we want to sort them. We want to sort them from, because we want to see the bigger number. So what you do is when you go to this button called sort filter, can you click? We are here, right? We are somewhere here. Just click this sort filter. We want to do largest to the smallest. Okay, largest to the smallest. So when you click largest to the smallest, you will see this. Okay. What it tells you is these 3 respondents, they have 18 items which they did not answer. First respondent, second respondent didn't answer 18 items, and the third respondent didn't answer 13 items. These three numbers we need to delete. Okay, so we started with 197. Now we will delete these three cases. Okay, when you are writing your report, yeah, and this stage, right? You need to write, no? Okay. We screen for blank responses. We found how many cases, blank responses. You need to write that first, huh? Okay. So, and the case, later you can write the case number. We see the case number 43, 189, 101. These are the three cases which has lots of missing numbers, huh? So what you need to do now is you need to write here, click these three items. We don't want these three cases. We will throw away these three cases. So what you do is you right click, delete them. So what will happen is now you don't see the three cases anymore. See the blank response? We don't have the three cases already. Okay. So this is the first screening we will do for blank responses. Okay. So then what we will do is we will remove this. We don't need this anymore. Okay. So what we have done is we have done this, which is this one. Can you see this missing value? This is what we have done. Now we are moving to the second one, which is called straight lining. A straight lining is when the respondent answers the same answer for all questions. He is not reading. He or she is not reading. They just tick 4, 4, 4, 4, 4 or 7, 7, 7, 7, 7. This is what we don't want. So this kind of cases, we will also remove. Okay. So when we go back here, we will go back to our Excel. So now what we will need to do is we will put a name called SL. So you can use any name, doesn't matter. SL. What is meant by SL is straight lining. Straight lining. Okay. Can you label first? SL. Okay. How do you detect straight lining is when they answer 4, 4, 4, 4, 4, the standard deviation will be 0 because the mean value is equals to the average value. So the average value is equal to the actual number, right? So the function we want to do is equal STDEV. You'll see this, right? STDEV. Okay. This one, STDEV. And you will double click. They will open the bracket, right? The same thing we did just now. You will need to do this. Highlight all the item. Okay. Not for your demographic variable. These are all the items you have in your model, your research model. Only for your items. And then we will close the bracket. So when we close the bracket, they will give you a standard deviation here, right? Okay. Can you see the standard deviation? Okay. We are actually trying to find out which cases has a standard deviation of 0. Okay. So what we do is the same thing. When we get a plus sign, just double click. Okay. Just double click. So what will happen is they will calculate the standard deviation for all the variables you have in your model, right? Okay. What we want to find out is the zeros, right? So we need to sort this column from the smallest to the largest. Okay, from smallest to the largest. So when you click this button here, sort. Okay, just now we were sorting from largest to smallest because we want the larger number first, right? But now we want the smallest to the largest. Okay, just click this. Okay, so now you can see two cases which has this problem called straight lining. Straight lining. These two cases, right? Okay. So we started with 197 respondent. We deleted 3 cases because of blank responses. Now we are going to delete 2 more cases because they were straight liners. Okay, straight liners. Huh? Okay, so what we will do is we will delete these 2 cases. Okay, and this column is no longer needed. Huh? Okay. Okay, so any questions on these 2 blank responses and straight line? Nope. Okay. Okay. So what we will do now is we need to sort this. Huh? Okay, these numbers are not sorted properly, right? Can you sort the number from smallest to largest? This one, huh? This column. Can you sort it from smallest to largest? Huh? Click here. Smallest to largest. Huh? Okay. We deleted 5 cases, right? Okay. But the number is still 197, right? It should be 192. 197 minus 3 minus 2, right? So it should be 192. Huh? So how do we label them? You just click from the first cell, right? Shift, control, and arrow down. One time only. Huh? Shift, control, and arrow down. If not, you have to drag. For those who are using a MacBook, I'm not very sure what is the function key. Shift, control, and arrow down. Okay. Everything is highlighted, right? Okay. What you need to do is you want to number them sequentially. Yeah. So you have this function called fill. Can you click this fill? Okay. When you click the fill, we have series. Can you see the series? Okay. So we want to use a step value of 1. See, the first number is 1, right? It will take 1 plus 1, 2. 2 plus 1, 3. 3 plus 1. So the step value is already correct. What you need to do is you just click OK. Yeah? So what will happen is now your number will be numbered correctly from 1 to 192. Okay, 192. Huh? So now we have already done this stage called the blank responses and straight lining. Huh? So now we want to do this data, which is still 197, right? SPSS data, just click the delete. They will ask you, do you want to remove? Just click OK. So we are done with the deleting the data. So what we want to do now is we want to copy this data. Okay. This data. Okay. The whole data set. Can you see the data set? Okay. You can do this. Let me try. You can click shift control arrow to the right. But you need to go on until you get the last one, which is, okay, until here. Shift control arrow to the right and then press the arrow key to the right. Once you have all this highlighted, shift control arrow down. That will give you all the other data, right? Okay. Now we can copy. Okay. And in your SPSS, right click and paste. Okay. Now what will happen is now you will get 192 cases which are already clean. Okay. Anybody has a problem with this? 192 cases, right? Okay. So I will save this. Yeah. Any questions on this part here? Import, define, screen, and clean the data. So All this you need to write later in your report. I've given you a template. You can look at the template, how to write. Okay. So this is the first three we have done. Then only we will move on to this step called reliability of variables. Hopefully I have here. No, okay. Before that, we also have a problem called data entry error. Data entry error. Data entry error is like this. The gender is actually female, but you put as male. Okay. Or the answer is 5, but you put a 55. This one you need to detect. Okay. If your answer is actually 1 female, right? But you key in as 2, the software will not be able to detect. If you use SPSS, you will not be able to detect numbers which are within the range. Any number outside the range, let's say gender is 22. There's no gender 22, right? Gender is 1 and 2. That can be detected using SPSS. So data entry error, which are keying in error, we will do sampling. Let's say we have 1,000 questionnaires. We take 10% of the questionnaire, and then we will go question by question and check how many was entered wrongly, the numbers. Okay, that is called sampling. 10% of the total number. The one we can use SPSS is like this. So if you go to your SPSS, okay, we will do this. Can you go to analyze, descriptive, and descriptive? Analyze, descriptive, descriptive. Okay, when you click the descriptive, what will happen is the software will show you this. You can actually drag down. For those who are not very familiar, you can actually drag down here. You can see everything, right? Okay. So we want to select from the top to the bottom. Not the ID, not the ID. And then select it to the right. Select it to the right. Okay. So once you click OK, can you look at the numbers? Do you see any numbers which are out of the norm? Yes? Yeah, okay, age, song, You have a problem with age, right? Nobody age 500, okay? You need to check them, right? Any other things you see? If you're 500, you will not be filling up a questionnaire, Yeah. Any other numbers which are out of the norm? Okay, gender, right, Amir? Gender, correct. Gender, you have 22, right? Okay. Gender is only 1 and 2. So these two variable, which is gender and age, right? The numbers are out of the norm. So we want to check. Okay. So how do we know is we can do this? You can go under analyze. Okay, analyze reports. Okay, especially when your data set is very large, right? We want to point which one is a problem one. So you go to reports, and then we have this case summaries. Case summaries. Okay. If you click the case summaries, just now we already decided the two variable we had problem with was your gender, okay, and age, right? So we need the ID. We will click in ID. We will click in gender. We will click in age. Okay, these are the three. Okay. And then at the bottom here, we have a limit 100 cases, right? We don't want this. We want to unlimit, right? If you put 100 only, then they will only list you 100 cases. After 100, they will not list. Okay, I don't want this, right? We just remove this. Okay. Then we click OK. What will happen is they show you the numbers. Can you see? Okay, now you can see clearly, right? Number 17. Okay, here, analyze. Okay, let me move this a bit now. Okay, go to analyze this reports. Somewhere, and then case summaries. Okay, then you get this, right? Okay, Song? Okay. So we selected ID, we selected gender, we selected age, right? Okay. And then when we click OK, you can see here case number 17, case number 17 or respondent number 17, we have a 22. And then respondent number 12, we have an age of 500. So what you need to do now is you check number 12 and 17. Pull out the questionnaire, check what is the actual number. So the actual numbers are supposed to be like this. This is supposed to be 2. And this is supposed to be 50. Okay. And then we will save. Okay. Here I actually did the entry error. That's why I know what is the number. But you have to go back to your questionnaire to check. Okay. You have to go back to your questionnaire to check. So this is how we counter check data entry error using this method called SPSS. Okay. But if your answer is actually 1 and you put 2, the software will not detect because it's still within the range. That's why we have another method called sampling. Okay. So, yeah. Okay. So we have done with the first time. So we have done number 1, number 2, number 3. Yeah. Okay. Any questions on number 1, number 2, number 3? Okay, because I entered the data, so that's a question she asked, right? Okay. Okay, why I changed it to 50 is because I am the one who did the entry, yeah? So you are actually supposed to go back to the questionnaire to check. Okay, from the questionnaire. Same with the 22, right? Just now I changed it to 2 because I actually know that the person is female, but we double enter. Instead of 2, we key in 22. That's why we are changing it to 2. Before you run further analysis, we have done screening and cleaning. Okay, so this is what is called pre-processing. Okay, any question? Any other question on pre-processing? No. Okay. So now we will move on to the next stage. Okay. Okay. Before we do data transformation, we actually have a function called, let me see. Do I have reliability? How come I miss reliability? Okay. Okay, so I will show you this analysis. So this reliability, correct. Okay, I forgot about reliability. Okay, this one. So before we can do other things, we want to do this reliability analysis. For reliability analysis, we want to see whether the answers for the same variable is consistent or not consistent. I think most of you are exposed to a value called Crumbux alpha. But Crumbux alpha has already been criticized for a long time. So these two authors called Hayes and Coates in 2020, they came out with explanation that you should no longer use Crumbux alpha. You should now be using this measure called McDonald's omega. And this McDonald's omega is only available in SPSS 27, 28, 29, and 30. If you have SPSS 26, they will not have McDonald's omega. Okay, that's the first thing. So when we run this analysis, this is where we will go to. We will go to analyze scale reliability analysis. And in reliability analysis, we will run variable by variable. That means you pick one variable and then you pick the items from the left to here. and then we will click this button called statistic. These are the three things we need. Why we need this is they are actually for diagnostic purposes. Diagnostic purposes. Okay, so let's say I run like this. Reliability values, the cutoff value is actually 0.7. There are many literature that you can refer to. Reliability should be about 0.5, 0.6 or 0.7, but most literature will tell you 0.7 is the number. Okay, here we have no values, right? But what it tells you is if you delete this item number 2, your reliability will improve to 0.973. So what you can do is you go back to the analysis. In your analysis, we will remove attitude number 2. If you remove that and you rerun, the result will become higher. Okay, but before you do this reliability analysis, we need to also do another step called recoding. Recoding. So I will show you. Okay. Okay, so we will want to do an analysis called recoding. Okay, so for this stage, we will have a function called transformation and compute. Compute and recode. Okay, now we are into number 5. Number 5. Okay, this one I will come back a bit later. Okay, for number 5, what you need to do is you need to use a function called compute and recode. Okay, compute and recode. And these are done for some reasons. Sorry. Okay, there are two things you want to do with transformation. Number one is called compute. Number two is called recode. Number two is called recode. Okay. For number one, why we need to do compute is because of this. When we do modeling in social science management research, we want to regress this variable called attitude on this variable called intention. But in our data, we don't have a variable called attitude. We don't have a variable called intention. Okay, we don't have. We only have item 1, 2, 3, 4, 5, and also 1, 2, 3, 4, 5. So what we need to do is, in SPSS, we need to do this function called compute. So the statistical term is called summated score. Summated score. So this is where we will run this function called compute. Okay. When we run this function called compute, we can use mathematical operators. We can use log, we can use sum, we can use mean, those kind of values. So when we run this analysis, we want to compute a variable called attitude. And on the right-hand side is the numerical expression. This numerical expression we'll get from here. This function group here, we have a long list, right? We can actually pick from here. And when we do this mean computation, we are telling the system we want to compute this attitude number 1 to attitude number 5. Okay? Once you do this, what will happen is in your data, you will get a variable called attitude at the end of your data. Okay? At the end of your data. This is why we need to do this function called compute. And this function called compute is very, very, very important in SPSS. Without compute, you cannot run further analysis because your data only has items. You do not have the variable yet. Okay? You don't have the variable yet. That's the first transformation you can do. Okay, the second one is called recoding. For recoding, we have two types of recode. Number one is to recode into the same variable. And the second one is to recode into a different variable. Okay, when you can use them, I will explain. We will use a lot of recode into different variable. Only one situation we will use recode into the same variable. This is usually when you have reverse coded item. Okay, reverse coded item. So first step is this is the first reason why we use recoding. Okay, we collected data which is age, okay, actual age, which is 15, 16, 17, 18, 19, 20, whatever, right? So, but what we want to do now is we want to group this continuous variable into categories, okay? Any number within 15 to 25, you want to recode them into number 1. Any number 26 to 35, you want to recode them into category number 2. Anything more than 35 will be recorded in category number 3. Okay, why we do this is for some analysis, we require data like this. For some analysis, we require data like this. So, for example, we have a test called cross-tabulation. We need data like this. So, this is the first instance why we do recoding. The second reason we do recoding is like this. Let's say you collect data about ethnicity, Malay 100, Chinese 80, Indian 30, and others is only 4. So you cannot have one category with 4 respondents. Usually one category must have at least 30. Okay, 30. Yeah. So what we will do is we will now recode number 4 to become 3. Okay. See, recode number 4 to become number 3. And now your number 3 will become Indian and others, not Indian, because you have combined these two categories. Okay, the number will be 34. This is the second reason why we do recoding. Okay, recoding. Okay, the third one when we do recoding is like this. We have 2 items to measure how smart a person is. But one question is I am smart, and the second question is I am dumb. Okay, when you ask I am smart, they will answer 5. I am dumb, they cannot answer 5. If they answer 5, something is wrong with them. Okay, they will answer 1, right? If you take the average, 1 plus 5, you get a 3, right? Is this person smart or dumb? Number 3 is not sure. Okay, number 3 is not sure. Okay. What will happen is 5 plus 1 is 6, 6 divided by 2 is 3, right? So the conclusion is this person is neither dumb nor smart. But this is not correct because this item called I am dumb is a reverse coded item. Reverse coded item. You need to reverse the number. If you see a number 1, you reverse them into 5. If you see a number 2, you reverse them into 4. If you see a number 3, you reverse to 3, 4 become 2, and 5 become 1. So when you reverse code this number 1 to 5, 5 plus 5 divided by 2, you get 5. Okay, that is why we need to do reverse coding for items which are like this. So in your assignment also, you need to look at the items in the questionnaire. Do you have any reverse coded item? You need to reverse code them first. Number 4 is what we call as dummy coding. This is when you have categorical variable like gender 1 and 2. You want to use them in your regression. We cannot have 1 and 2. We will need to do 0 and 1. Okay. Later I will show you how it is done. And the last one is we have a continuous variable. We want to regroup them into 2 or 3 categories. Let's say we want to regroup them into 2 categories. We will use median. If we want to recode into 3 categories, we will use percentile. Okay, I will show you how this can be done. So these are the 5 situations where we will do recoding. Okay, so that is number 5. Okay, compute and recode the variables as necessary. Yeah. So okay, so we will stop here for our break. We will take a 15-minute break for those who want to pray and so on, right? Okay. And then we will continue at 7:30. Is that okay? Or you want a longer break? Yeah, 15 minutes, okay, huh? Okay, so, okay. 20 minutes, I give you 20 minutes. Huh? So we will continue at 7:35. Okay, 7:35. Huh? So we can finish off earlier. Huh? So I will, please come back at 7:35. Huh? Okay, welcome back. Huh? Before the break, we were looking at these two procedures called transformation. For transformation, we will do recoding and compute. Huh? And one of the most important function in SPSS is this function called compute. No? But we will do the recording first before we look at the compute. No? Okay. First, we will look at recoding into a different variable. So we have this data, which is actual age. Age is measured by actual age, 14, 15, 16, 17, 18, whatever number. Huh? So what we want to do is we want to recode them into three groups. Huh? Okay, this is where we will use the function called transform recode. No? So in the software, if you go to transform, we have two options. Recode into the same variable and recode into a different variable. If you recode into the same variable, the original values will be overwritten. And that is why we don't want to do that. So we will pick the recode into a different variable. Okay. Okay. Do you have these long labels? Yes? No? These long labels, right? Okay. We can actually change them. Okay. What you do is like this. Easier to see. Go to under edit. Go to edit. Go to edit. And then you have option. Edit options. Okay. And what you do is, if you see here, there's a display labels, right? Instead of display labels, untick and tick this display names. Okay. When you click display names, we will click apply. Yeah. Originally it was display labels. That's why the long names. We tick the display names and then apply. Okay. And now if you go back, analyze, transform, recode into a different variable. Now, can you see a shorter name now? Okay. See, the names are all short, easier to see. Okay. The variable we want to pick is the variable called age. Okay. We want to recode age into three categories, right? 15 to 25 as 1, 26 to 35 as 2, and above 35 as 3. So we will pick, first we need to pick the age. And the new name will be age group. Okay, this new name can be any name. Okay, but it's easier for you to remember since we want to group them together. I put a name as age group. Okay, so what we are telling is we want to recode age into a variable called age group. We have to click this button called old and new values. So when you click the old and new values, okay, you can see here, right? On the left is your old numbers. On the right is your new numbers. Okay, left and right. So now we want to record this number, right? Okay, 15 to 25, right? Okay, so we need to slots, right? So what we do is we cannot pick number 1 here, right? Here is when you want to change number 4 to become 3, number 2 to become 1. Huh? So here we need to take the range. Okay? 15 to 25, right? These are the old numbers. Any number from 15 to 25, we will record them into a new number called number 1. Okay? Just click the button add. No? Okay? So any number 15 to 25, it will be recoded into number 1. Okay. Number 26 to 35 will be recoded into number 2. Okay. You cannot start with 25, right? Because 25 is the last number in your group. So the next number will be 26 so that they don't overlap. Okay. They don't overlap. No? And you click the button add. Okay. Now we have already done 35. But for the third category, we don't know what is the last number, right? So what we will do is here we pick the last one here, right? Range. So we will put 35, No, 36, 36, Any number greater than 35 is 36, right? 36 through highest will be new number 3, So when you do recording, we have 2 rules, two of the rules is categories cannot overlap. Right? We call them mutually exclusive. And then the third one is collectively exhaustive. That means all the numbers must be able to go into one of these groups. That is called collectively exhaustive. So once we have done this, we will click continue. We need to click this button change, or else this will not become active. Okay. Once you click the change, and then you click OK. So what will happen is if you go to your data, at the end of your data set, you now have a new variable called age group, which is 3 groups in here, 1, 2, and 3. So now what we need to do is we need to label them. So here is the data. We need to click the variable view. Here we don't want 2 decimal because it is 1.00, 2.00. We remove the decimal. And then under the value labels, can you go to value labels, this column here? Okay. So number 1 is 15 to 25 years. Okay. That is category number 1. Then we click the button add. Okay. Number 2 is 26 to 35 years. And category number 3 is more than 35 years. Okay. So what we are now doing is we are telling the system for this variable called age group, if you find a number 1, they are actually 15 to 25 years old. If you find a number 2, it's 26 to 35 years old. And those who are in group number 3 are more than 35 years old. Okay, that's how you do labeling. After you create a new variable, you need to also add the labeling. So this is record number 1. Record number 1. Okay, then we want to do the other one. We will skip. I think we will do this. Another option we have is for recoding into the same variable. This is where we have this 5 item for attitude. Can you look at the item? Okay, all the 5 items are supposed to be positive. Okay, but we have 1 item which is not, which is negative, right? Which item? Can you see? Yeah, item number 2, right? Item number 2. So if you look at your data, let's look at the data. Okay, can you see our data here? Okay, attitude number 2, right? Okay, so attitude number 1 is high, attitude number 2 is low, number 3 is high, number 4 is high, number 5 is high. So this attitude number 2 is the one we need to record. And before you record, you need to know the categories. Here we have only 5-point Likert scale, 5-point Likert scale. So what we will do is, if you see now, this number 1 will become 5, number 2 will become 4. So 5, 4, 4, 5, 5, 5, right? So you go to transform, record into the same variable. Record into the same variables. Okay. We want to pick attitude number 2. Okay, again, if you have many items which you need to recode with the same 5 categories, reverse coding, you can put many of them here. Here I'm only doing one because in this questionnaire, there's only one item. So we pick this item called attitude number 2. And when you click the old and new values, okay, let me pull it this side. Okay. Okay, this is where you need to tell them how to reverse the code. No? So now ours is 5 categories. 1 will become 5. Okay. 2 will become number 4. 3 will remain number 3. 4 will become number 2. And 5 will become number 1. Okay, again, if you have a 7-point Likert scale, please don't follow this. If you have 7-point Likert scale, number 1 will become 7, number 2 will become 6, number 3 will become 5. That's how you reverse, okay, depending on your scale. So ours is only 5-point scale. First, we have done this, and then we click continue. We need to click this button OK. So now what will happen is your 1, 2, 2, 1, 1, 1, this will change into 5, 4, 4, 5, 5, 5, 5, 5. This is what we call as recoding. So I click OK. See the recording? They give you a syntax. Okay, now you see the numbers that they have already changed. So they're all in the same direction. So if you, for your project also, when you get your data, kindly look at the questionnaire. In the questionnaire, you need to identify questions which are negatively worded, and then you reverse code them first before you can begin any of your analysis. Okay. In this case, we have only one item. Yeah. Any questions on reverse coding into the same item? You cannot, because if you don't do the 3 equals to 3, they will not record. They will not change from one. You can try and see but I usually do this Okay, so we will save the data first. Okay, so that is reverse coding into the same variable. Okay. Another thing we will do is we want to do dummy coding. Okay, let's say if you have a model like this, gender, ethnicity, satisfaction, and commitment. Gender is 1 equals to male, 2 equals to female. Ethnicity is 1 Malay, 2 Chinese, 3 Indian, and 4 others. This is continuous. So when you have a model like this, you need to dummy code this variable. You need to dummy code this variable. Then only we can run the regression. Okay, when we can run the regression. So if you have 2 categories, quite easy, right? 2 categories, we need to create only one dummy. Okay, let's say we have 1 equals to male and 2 equals to female. What we will do is we will need to have 2 minus 1, number of category minus 1, which is 2 minus 1, you need 1 dummy. So we will record gender 1 equals to male, 0 equals to female. Okay, so the 0 female is actually here. Can you see here? This is called the benchmark group. What we want to compare is this one group, are they higher than or lower than the female in terms of your dependent variable. For example, we want to see the relationship between gender and salary. Let's say we regress this, we get the equation salary equals to 1,000 plus 2,000 times gender. Okay. If the gender is male, how much is the salary? 3,000, right? Okay, just substitute the gender equals to 1. 1,000 plus 2,000 times 1 is 3,000. Huh? Let's say the gender is female. How much is the income? 5K, 5,000. 2,000 times 2 is 4,000. 4,000 plus 1 is 5,000. So what they are saying now is when gender increases from 1 to 2, you get increase of salary of 2,000, which does not make sense because gender is not increasing or decreasing. So what we will do is we will now recode this variable. 1 equals to male and 2 equals to female. So the equation, the whole equation will work for the male, but for the female is only this part here. Okay, this part here. Because 2,000 times 0, see here, female is 0, right? 2,000 times 0 will be 0. So 1,000 is your benchmark. Okay, now you want to compare whether the male has higher salary or lower salary than the female group. That's all. This is like a t-test, but we are doing it in regression. Okay? For two groups, very easy. You just recode them into 0 and 1. You are done. But let's say you have 3 groups like this. When you have 3 groups, you need 2 dummy variables because number of category is 3. 3 minus 1 is 2 dummy. So we will write dummy 1 and dummy 2. Then we have to pick out of these 3 groups, which one is your benchmark? Which one is your benchmark? Let's say we pick managers as the benchmark. We will put a 0 and 0. Then we put 1, 0, 0, 0, 1, 0. What it means is your dummy 1 will represent technicians. Your dummy 2 will represent engineers. We want to compare technician against managers. We want to compare engineers against managers. Okay, so when we run regression later, we will put D1 and D2, not your position. Okay, not the original position. If you have 4 categories, then you have to create 3 categories, right? 3 dummy. Number of categories, 1, 2, 3, 4. 4 minus 1 is 3. So we have dummy 1, dummy 2, dummy 3. We need to first pick which group is the benchmark. You can pick any group as your benchmark. Just remember that. You just have to put the 0, 0, 0 for the benchmark group. Then the first category will be 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. So what happens is dummy 1 will represent Malays. Dummy 2 will represent Chinese. Dummy 3 will represent Indian. The benchmark group is the others. So you're comparing Malay against others. You're comparing Chinese against others. You're comparing Indian against others. Okay, that is the reason why we need to do this dummy coding. Okay, so we will do one dummy coding here, which is gender. We have a gender 1 and 2. We want to recode them into a dummy variable here. So we will go to analyze, transform, recode into a different variable. Recode into a different variable. Okay. We will click the button reset because we don't want the original. So we will pick gender and a new name called and gender dummy. I label this as gender dummy. Okay. So under the old and new values, number 1 will remain number 1. Okay. Number 2 will become 0. Okay. So now we have 0 and 1. A dummy is actually 0 and 1 on here. Okay. So we will click continue. Click this button change. And then click this button OK. Okay. So now you have a 1.00. We don't need the 00. So what you do is you go to variable view. Under the variable view, the last column here, right? Okay, here. Change it to 0. Change it to 0. So once you change it to 0, when you come back to your data, you see this variable called gender dummy, which is 0 and 1. Okay, 0 and 1. Okay. Any questions on dummy coding? Huh? Oh, okay. And the last recoding we will do is this. We will do compute first so that we can do recoding. We want to compute the variable called intention. Okay. And then we want to recode intention into low and high. So can you go back here? Okay. So under transform, can you click the compute? Transform compute. First, they will ask you a name. The one we want to create is called intention. Intention. That's one variable we have in our data. And then in the function group here, click the all. All, they will show you all here. We want to take the mean values. Can you find the mean value? Mean. Okay. How do we select this function? Just click this arrow on. Okay. So they ask you a question, right? There are 2 question marks, right? Why are there only 2 question marks, not 3 question marks or 4 question marks? Anybody? Yeah. Why 2 question marks? Not 3, not 4. Okay. Later you will also learn this. To calculate mean values, you need at least 2 values. 2 values, not 1. 2 values. You can have more than 2 values, but not less than 2 values. So what it tells you is, I need 2 items at least to calculate the mean value. So how do you do that is, if you go down here, you have this item, intention 1 to 5, pick this item. Instead of putting item 1, item 2, item 3, we will do 2, and then pick the last item. We want to calculate the mean value of item 1 to item 5. Okay, item 1 to item 5. Okay, so now we click the button OK. They have done this calculation. If you see at the end of your data, you have a new variable called intention, which is the average of the 5 items. Okay, again, when you do this transform compute, let's say you run reliability later and you deleted some item between item 1 and 5, cannot use this function. Okay. If you don't delete any of the item, then we can use this function easily. Okay. That's the reason why I'm showing you this. So this is the variable we got intention. So this is the function called compute. So if you see in our research model, let's say we have, just now we have 5 variables, right? 1, 2, 3, 4, right? We have 4 variables, but currently we don't have those variables yet. So we have already computed intention. We need to compute attitude. We need to compute subjective norm. We need to compute behavioral control before we can proceed. Okay, but we are not going to do that yet because we want to do another function called reliability analysis. Okay, so before I show you the reliability, we will do this recoding into 2 categories. Okay. So to record the variable called intention into 2 categories, can you go back here? Okay, we will go transform, recode into different variables. Transform, record, no, sorry, before that, we need the median value. So can you go under analyze, descriptive, and frequencies. Analyze, descriptive, and frequencies. We will pick the variable called intention. Just pick the variable called intention. Okay. And then under the statistics, can we get the statistics? statistics. Okay. Here you can see this is highlighted, right? So this function belongs here. If you change to chart, they will change here also. If you click the chart, cancel. If you click the chart, they will give you a different option. So we are now doing statistics. Okay. What we want is the median. Okay. If you want 3 groups, then you click here, percentile. The first percentile is 33%, and the second percentile is 67%. This one, they will split into 3 equal groups. Okay, this is 2, this is 3. Okay, 2 and 3. Just click continue and OK. What they will do is they will give you a result. The median value is 4. The 33rd percentile is 3.8, and the 77th percentile is 4. So we want to recode using the median. Anything below the median is low. Anything above the median is high. We are now creating 2 variables, low and high. So we will go under transform, recode into a different variable. Okay. We will click the button reset. We want to pick the variable called intention. And the new name, I want to name it as like this. Intention category. Intention category. Okay. After we have created the intention category, we will need to click the old and new values. Just now we already saw the median value was 4. Median value was 4. So anything below 4 will be low. Anything above 4 will be high. So what we need to do is we will pick the button here, range. Any lowest number through 4.00, the new number will be 1. Okay. Any lowest number through 4 will be number 1. And then the next number will be 4.01. Will be 2. Okay. They cannot overlap. Here 4 is 4.01. So this group number 1 will be labeled as low. Group number 2 will be labeled as high. Okay, low and high. Just click the continue. And then click the change button. And then OK. So what will happen now is in your data file, at the end of your data file, you have a new variable called intention category, which is 1 and 2. This 1.00, 2.00 is not required. So what you do is under the variable view, change it to 0. Change the decimal to 0. Now, if you come back here, you have only 1 and 2, right? So under the variable view, we need to also do the value labels. Number 1 is low, and number 2 is high. Okay, so this is how we do labeling for the 2 categories. So any number which is 1 is low, any number which is 2 is high. So this is how you regroup your data from a continuous variable into 2 categories. Yeah, any questions on regrouping? Okay, so if you see here, we have this, right? Can you see here? Categorize the variable intention into 2 categories. Okay, yeah. Any questions before we look at the reliability? We have not looked at the reliability yet, right? Yes, any questions? No? Okay. Okay, so I will show you one reliability analysis. So if we go to analyze, scale, reliability analysis. Huh? You need to run this reliability analysis variable by variable. Huh? Say attitude, intention, subjective norm, perseverance control, all one by one. Huh? So click the reliability analysis. Okay. We want to run analysis for item attitude number 1 to attitude number 5. Huh? And then we have to click this button called statistics. Okay, can you click here? Item, scale, and scale if item deleted. This 3 is needed, huh? So that you have an option if you want to change. Huh? Okay, most of you are familiar with Chromebox Alpha, right? But Chromebox Alpha has already been criticized for a long time. Huh? There are some articles written with the title, Thank You, Coefficient Alpha. We will take it from here. That means they're telling Chromebox Alpha to rest in peace. Huh? Okay, so now they have introduced a new reliability. You have to click this button down. Yeah. Okay, just click continue first. Sorry. And then click here. Can you click here? You will find Omega. The only problem with Omega is you need 3 items minimum to calculate Omega. 2 items, they will not calculate Omega. You can go back to Chromebox Alpha. No choice, right? Okay. So we want to calculate Thomson Omega. We pick this. And once you click OK, what will happen is they will give you a table like this. Okay. Now you have to listen carefully. This table will give you overall reliability. Like I already mentioned, reliability values in different literature, they give you different numbers, 0.5, 0.6, and 0.7. 0.5, 0.6, or 0.7. This is already higher than 0.7. But if it's lower than 0.5, then you can actually look at this table. Okay, item total statistic, right? What they will give you is with all the 5 items together, and there's a column here, right? What will happen to your Omega if you delete item number 1? If you delete item number 2, what will happen to your Omega? Okay, here, this is already very high, so you cannot delete any more item. Okay? But what happens is, let's say I'm showing, you don't have to do this. I just show you what happens if, let's say you have a data entry error. Okay, instead of 4, you key in 44. Okay, this is the only mistake you did. And now if you run your Omega, okay, what will happen is now you get a different result, right? You get a reliability Omega of 0.582, which is very much lower than 0.7. This is where the table becomes very useful. Can you see? Okay, we have this column called corrected item correlation, corrected item total correlation. If you find any number less than 0.3, those are not very good items. Okay, here we have a 0.290, right? So if you see here, if you delete item number 1 from the analysis, your reliability will go up to 0.966. If you see the change is very big, right? Okay. This is where you need to go rerun and remove the item. So when you compute later, you only compute with attitude number 2, 3, 4, and 5. Not number 1. Number 1 is removed in the analysis afterwards. Okay? Any question?
Hello, sir.
Yeah.
For the older version of SPSS, we don't have Omega. Is that okay?
You need 27, 28, 29, or 30.
26.
26 don't have.
Yes.
No, I already shared 27. Yours is Mac or Windows?
Windows.
Windows, I already shared the Windows version. You can do a crack.
Okay, thank you, doctor.
Okay. So, okay. Anyway, so that is number 1. So for reliability, what you need to do is to run reliability. Just now we ran for attitude, right? So you remove the attitude and then you put in your subjective norm. Okay. Now you get a different number, right? Okay. This is the Omega for subjective norm. Anything need to delete, you don't need to delete. So you have to run this for all the variables you have in your model, which are multiple items, not for categorical variable like gender. Okay. Anything else? Okay. So we have covered number 1, number 2, number 3, number 4, number 5, and number 7. Okay, I've already covered them. These are some questions you need to do later. These are some analysis you need to do. After you do this, you need to do this analysis. We will cover in the subsequent classes how to visualize, how to do a t-test, how to do a cross-tabulation. That one will come a bit later. But at the moment, you can already do all this. I will also quickly go through this number 6. Describe the sample profile, right? Okay, so that we can finish all this. This one we have to wait a bit. Yeah, they have literature saying 0.5, 0.6, 0.7. Fatin, you can look at the literature to cite which one. We have different literature by different authors, so you can decide. Okay, for profile, you need to look at 2 things. First, if you go back to your questionnaire, okay, we have 1, 2, 3, 4, 5, 6, 7. Okay, out of these 7 variables, right? 7 demographic variables. Which ones you can run frequencies? Frequencies is count. How many male, how many female. Yeah, song says 5, 6, 7. 1 also. Okay, 1 also, correct. So number 1, this is categorical, right? Number 5 is categorical. Number 6 is categorical. Number 7 is also categorical. So for these 4 variables, you will run frequency analysis. For these 3 variables, number 2, number 3, and number 4, we will run descriptives, okay, which will give you mean, standard deviation, skewness, and kurtosis. Okay, so how do you run your frequencies? Okay, let me go here. Okay, go to analyze descriptive frequencies. Okay, again, this will be covered in the subsequent classes, frequency, descriptive, and so on. But I want to quickly show you this, right? Okay, we will pick gender, we will pick department, position, education, and okay, I have okay, this 4, right? Okay, can you do that? And then when you click OK, what will happen is you get a table like this. So you have 75% of your respondent male, 25% of your respondent female, and then for department, most of them are in the engineering department. And then if you look at position, most of them are engineers, right? Engineers and senior engineers. For level of education, most of them have a first degree or a master's, PhD, right? Because they're engineers. So this is how you run your frequency analysis. But after you run these 4 tables, you need to do some summary. Later I will share with you how to do tables, a proper APA table. Okay. This is only for categorical variables. For the continuous variable, you run analyze, descriptive, descriptives. Okay. So the 3 variables we want to pick is work, age, organization, work. And also, when you compute your variable, like intention, right? We can also run descriptive. Okay, after you pick the variable, under the option, just click here, okay, the option. we also need the kurtosis and skewness. Okay. Default is mean, standard deviation, minimum, maximum. Actually, minimum, maximum, not needed. If you don't want minimum, maximum, is also okay. This is only to check whether you're within the range. So I will untick this. You don't need. Just click continue and okay. What will happen is you get a table like this. We have the mean, we have the standard deviation, we have the skewness, and then the kurtosis. What do they mean? In subsequent classes, we will discuss about skewness and kurtosis, mean and standard deviation. So this is the table you will be reporting for the descriptive analytics. Okay, descriptive analytics. How to prepare the table, I will also share with you some slides. How to do tables APA format. Okay, APA format. Okay, so now we go back. So these actions are all done. So I've already covered all this, how to do with SPSS. So the data file for the project already given to you, I think yesterday, day before yesterday, right? These are the 4 files you have. This is your instruction. The first file is the instruction. The second file is a template for writing your report. The third one is your data file. And the fourth one is the template for your project. Okay, the project will be multiple regression. That will happen only towards the end of the class. So this is the template you can look at. So I've already given you how to do because I find many of you have problem even with word processing. I think you have to attend some classes how to do word processing also so that your report will look very professional. So you have your assignment. So the same data set will be used for your assignment and your project. Okay, this is the cover page for the assignment. And then you have this table acknowledgement, the format for report, all I've given here, spacing and so on. And then these are the content, okay, which you can actually get from the write-up I already shared with you. Okay, so you can look at each of them. Yeah, any questions on the first part of your assignment? The second part of the assignment will only happen after you have started doing your classes, right? Like we will learn t-test, we will learn one-way ANOVA, correlation, cross-tabulation, then we can answer all these questions. And then for your project, we need to do an analysis called multiple regression analysis. Okay, that will happen toward the end of the class. Okay, so we have 2 parts, assignment and project. They are 2 separate files. When you submit, you have to submit them in 2 files. One is assignment, the other one is the project. Yeah. Any questions on what we have already discussed so far? Yes, no? Okay, for those who have problem with your SPSS, the one I shared with you is the official link for SPSS 28 and 29 from the university. I'm not sure why some of your software is not working. It should work, and it will work until July. For those who still have a problem with the installer, I think I've already shared with you also this one. So I will show you this. SPSS 27, right? This one will work. Okay, this one. This is the link for SPSS 27. Okay. This is after you download, you need to run the to install. After you install, you can watch the video how to crack the license code. Copy and paste on it. It will work. But unfortunately, I think it's only for Windows, not for Mac. I'm not sure whether it will work for Mac. You can try it out. But you have to download, install, and then watch the video, how to do this. Homework you can submit from tomorrow until the 15th week. Wang, huh? I will create a link for you to submit. If you think you are ready to submit anytime, you can submit. Huh? We don't have, the deadline is the last week of your class. Okay, which you cannot do until you do your multiple regression. So you still need to wait. Huh? Yeah, any other question? Okay, next week we will still have online class. I think Dr. Ng is not around and the class size is very large. So we will still be online. Okay. Okay. Please tell your friends who did not attend the class. Next week we are still online. Okay, because we will have a combined class. So we will have about 600 to 700 people, right? So I don't think so we will have a problem. So yeah, the recording will be available after it becomes available. We will post it on the eLearn and also eLearn. You will get it from the eLearn. Okay, the link will be available for you to watch. Okay, if no other further question, we will stop here for tonight. Thank you very much. Please remind your friends. Yeah. Okay, you still want the new slides? Okay, I will share the new slides. Very few addition only. Okay. So I will share the slides after the class. So I will see you next week. We are still online. Okay, we will use the same WebEx. Okay. Okay, good night.